I was trying to build a short peptide from scratch in PyMOL the other day, and it took me forever to figure out how to add this carboxyl group right here on this end, the C-terminus right here. So I wanted to share with you what I've learned since I had trouble finding this on the PyMOL wiki. Maybe you want to model a particular amino acid sequence for yourself, or perhaps you're an instructor creating practice problems involving amino acid identification. This tutorial will help you build the sequence you want in PyMOL. Let's begin. Feel free to open a PyMOL window and work along with me. First, let's change our background to white so it looks good in a journal or a Word document. Click Display, Background, and set to white. Now click anywhere on the background to get ready to build. In PyMOL, you can generate amino acid sequences using the Builder. Start with the drop-down Build menu to select the secondary structural element you want to create. Here under Residue, we can select from these three, and let's start with a helix. Now you can click Alt on your keyboard, or the Option key if you're using a Mac, plus the one-letter code of the amino acid you'd like to add to your helix. So I'm on a Mac, so Option, L, and we have leucine right here. So we can quickly add amino acids to our chain, or we can add them manually using the Build drop-down menu, Build, Residue, Glutamate. Now I'm using Option click to move this over, and I can pinch my fingers to zoom out a little bit. Now, if you're using the key command, don't stare at the keyboard while you do this. I'm using version 2.3.4 of PyMOL, and a few of the amino acids don't work. For example, I'm pressing Option now and E, and nothing is happening, no glutamic acid. So I'll have to go to the Build menu and add this one manually. So as a side note, the ones that aren't working for me with the key command are E for glutamic acid, I, isoleucine, and N, asparagine. To double check your sequence, go to the Display menu and turn your sequence on. We can go to the Build menu, switch over to an anti-parallel beta sheet, and add more residues to our chain. Move my structure over and reorient it a little bit so you can see. So as you build, it'll continue to build along your sequence here. Although I'm not quite sure how to make a turn or anything like that yet. I think you might be able to place two objects and then connect them, but that's beyond the scope of this tutorial anyway. So notice on our helix, we started by building I got some clipping going on. We started by building from the N-terminus over here. And that's okay, that looks fine. This nitrogen here could correspond to our NH3+, and all is right in the world. But over on this side, on the C-terminus, this is waiting for the next amino acid. So it's just a carbonyl group instead of a carboxylate. And notice this structure overall looks a little funny. We have this kind of ribbon going along through our chain, and then we also have sticks. This is actually trying to overlay a cartoon plus sticks. So we could just go to the Show menu, Show as Sticks, and get rid of that distracting little line there. But for now, let's delete everything using the Action menu. To write sequence problems for students, I like to use the anti-parallel beta sheet because it's easy to orient the amino acids in a way that we can see the side chains clearly. So let's set up our new sequence. Go to Build, Residue, make sure we're an anti-parallel beta sheet. And I'm going to go ahead and use some that actually work with the key command. So again, I'm going to press Option or Alt. And then we'll do lysine, leucine, serine, methionine, aspartate, alanine. Okay, and for some reason now it's showing up as lines, so let's go back to our Show menu, Show as Sticks, since this will be the view that we want to use. Now, often the hydrogen atoms are not shown in renderings like this, but building from scratch puts the hydrogen atoms on. So let's give the more typical view of this by hiding the hydrogen atoms. This is a typed command. Hide hydro. Now let me reorient this a little bit. I'm just using my keypad. I don't have a mouse, and I'm just clicking on my Mac Option and click, and it allows me to move my structure. Pinching the fingers in and out allows me to zoom. Now, our goal is to add a C-terminus here, so people don't get confused that this is just ending on a carbonyl. So I'll open the builder now from this menu. Now, if this little white wrap, like selection thing, do you see that right there? If that's missing, you may need to go into the mouse menu and change into an editing mode. So just using my trackpad the way I'm doing, I can use this 2-button editing mode. And then if I click anywhere else, that'll go away. And if I want to add to this piece right here, I can click and that lets it highlight up again. So I could actually add on to any other part of this, but we just want to add right here for now. So now with this carbon of the carbonyl selected, I can go in my builder and click on the CH4, which will add a methyl group. Of course, we actually need this to be oxygen to make it a carboxylate. So click anywhere in the background, but not on the structure. That makes the little white selection tool go away. Now click on oxygen in the builder. It asks which atom we want to replace, and we click on our carbon. Ta-da! Carboxy terminus built. I'll apply the hide hydro command because notice this added a little OH on the end here, and that's not typically shown. So if I click in the command line, I can use the arrow keys on my computer up and down to toggle through any of the previous commands that I use. So I can just reselect this without typing, apply it, and we lost our little H on there. We'll close the builder. This is still asking me atoms I want to replace with oxygen, so I'll just click done over here. And now we want to reorient this so that it's easy to see the side chains. All right. So I'm just clicking and dragging on the white to move my structure without selecting anything. And we've got this one here that we really want to show the branching on. Okay, so I think that's showing this one pretty well. We could get the gist of our sequence now. So here's our N-terminus, C-terminus. We can see all these side chains, but the serine is pretty hard to see. We need to reorient that if we want somebody to identify this sequence. We'll do this using the mutagenesis wizard. So up in this menu, wizard, mutagenesis, and select protein if that's one of the options for you. And now it's going to ask you to pick a residue. So this is the one I want to change. So mutagenesis actually allows you to just move into different rotamers, or you can change the residue. So we're applying no mutation here, but just using our left and right arrow keys to move this around. So with the serine residue and that orientation, I think that somebody could identify all of these amino acid chains. So I'll click apply, and my structure has been reoriented. Now, if we want to recolor the backbone, we'll go up to this color menu, color by element to maintain our CPK coloring, and maybe I'll choose this salmon color right here. And to me, it's really important to make sure that my image is accessible to colorblind individuals. So I'm going to check this in a colorblindness simulator. I need to save this as an image file. This is telling me still to pick a residue, so I'm just going to click done, get that dismissed from here. Now I can save this as a PNG from the File menu. I can use this Draw Array button if I have it, and this will allow me to save an image to file or copy it to a clipboard to put it into a Word document. But I'm just going to use the command on my Mac to do a good old-fashioned screenshot and take a screenshot of this image. So now I'll visit my color blindness simulator website. Proanomaly is the most common form of color blindness, so this is a really important one to check, but you can check all sorts of different color blindness here. I'll choose my file, or I can drag and drop it, and it opens right here. So I'm in the normal view, and now I can Click on my proanomaly. And I see that, it looks okay, but we're kind of losing some of the contrast, particularly to these carbonyls that are pointing back and forward. It's just a little bit harder to see the contrast of the red against this salmon color. So I'll go back to PyMOL. I actually strongly favor this color scheme in set 2, where the carbon atoms are colored this kind of gray. And everything has some nice contrast. There are some others. Yeah, set 4 has a pretty good one where it's even a little bit lighter and the contrast is better. Now, if we pop this image into the color blindness simulator, check our proanomaly, and we can see the contrast is much, much better. With color blindness, color choice can be important, but it really seems to me that good contrast is key, so I tend to have my carbon atoms in these whites or light grays. Well, I hope you've enjoyed this tutorial and learned something. I research visual literacy with my NSF-funded team. If you're an instructor teaching visualization, you may want to check us out at biomolviz.org, and maybe in the future you can join us for a biomolecular visualization workshop. Thanks for watching.